Hello, my name is Hee-Jin RO. We want to present our article titled From Aspecto-temporal Analysis to Logical Modeling, a Generalized Theoretical Stage. If the human being has the capacity to perform aspecto-temporal analysis, the machine must be guided by explicit rules to obtain similar results. The use of computer science in an experimental mode will test the explanatory and operational strength of the aspecto-temporal theory. We propose a formal aspecto-temporal analysis to perform combinatorial calculations from an applicative expression. Such an analysis requires evaluation of the calculation at each stage, the structure of the expression, and its logical and semantic components. The combinatory logic of Curry, which is the applicative system for this presentation, has been used in a manner similar to a programming language, given that a program is a complex operator composed of multiple elementary programs. Indeed, the concept of compilers developed by Jong-Seok Soh starts from the applicative system. Therefore, functional programming languages are based on combinatory logic. To make a program in an applicative language, operators need to be composed among themselves. We focus on the application of combinatory logic in order to take a generalized theoretical position on the application of combinators, elementary or derivative, to aspecto-temporal operators. This presentation, with the result of formal application, shows that natural language, in our case English, can be transformed into a machine understandable and expression. Our work is based on the linguistic computational model of grammar of applicative, cognitive, and enunciative we called GRACE, particularly in the level of aspecto-temporal theory. The central concern of applicative grammar is the applicative operation, that is, when an operator applies to its operand. The linguistic computational architecture of GRACE is based on linguistic analysis and aims at a computer realization. Each level of GRACE is articulated for transformed representations. An utterance is the input of a categorical grammar, which results in an applicative expression. This model is analogous to program compilation and therefore can be implemented on machines using functional programming languages such as Haskell, F#, Camel, and Lisp. This model uses aspecto-temporal operators to analyze aspecto-temporal and enunciative phenomena that contains a propositional predicative relation with aspectual values like state, event, process, and relations on topological intervals such as open, closed, and semi-open forms. The GRACE model uses the combinatory logic of Curry, which is a unique formalism that represents each utterance in an applicative expression where various types of operators apply to operands. Combinatory logic was used by Sebastian Chaumian to describe and analyze linguistic phenomena, and this approach has spread to the cognitive semantic domain of GRACE as well. The applicative is a fundamental characteristic of combinatory logic. An operator applies to an operand to obtain a result. Combinators are abstract operators that compose or transform the operand it applies to. Combinatorial expressions are a part of applicative expressions. Elementary combinators come together to build more complex combinators. The meaning of each combinator is defined by its action in the form of a beta reduction by introduction and elimination rules. Consider an operator X which applies to an operand Y to result in Z. The application programmed from X to Y is denoted by a simple non-associative juxtaposition which prefixes the operator to its operand. Z equals XY. Some elementary combinators with their elimination rules, beta reduction, and the introduction rules, beta expansion, are presented in this table, where combinator I signifies identity. Combinators B and X extension B2 are functional operators of the composition. Combinator C represents a conversion of the two arguments of a binary operator, and the combinator C star changes the role between an operator and operand, and etc. Combinatory logic takes advantage of the formal analysis of natural languages. First, as in natural languages, there are no linked variables in the combinatory logic. Therefore, there is an ease of management of operations, unlike lambda calculus, which requires the management of linked variables to avoid telescoping, especially during substitutions. Second, combinatory logic allows the construction of complex operators from elementary operators and predicates, creating a possibility of showing how a lexical predicate or a grammatical operator can be the result of an integration process and the formal potentials of relatively complex operators. Third, combinatory logic has the flexibility that other formalisms, including lambda calculus, do not have, such as addressing quantification, determination, or typicality issues. Finally, combinatory logic appears as a primal logic at the confluence of several formalisms and at the articulation of several disciplinary fields, such as linguistics, philosophy, and computer science. The aspecto-temporal theory of the Grace model explicitly analyzes and represents the enunciative operations of an abstract enunciator. For this analysis of an utterance, we start with an abstract enunciative schema, where the abstract enunciator I utters something what is said, I say. This act of enunciation is a process using the operator pros, which takes place over an interval J0 closed on the left and open on the right, having been unaccomplished. Pros J0 I say. The metalinguistic operator of this schema I say is the result of the conversion of two operators I and said. The operator said expresses the metalinguistic predicate of utterance, and the operator I represents the abstract enunciator that can be substitute any occurrence of a concrete act of enunciation. The meaning of the enunciative schema is: an abstract enunciator takes charge, I say, what is said, with a certain aspectual aim, ASPI. This metalinguistic operator, ASPI, signifies an aspectualized predicative relation, ASP, realized in the temporal interval of I, for I. This act of enunciation is an unaccomplished process that takes place over an interval z0. Now we consider the following utterance A. The postman traverses his route. The formal metalinguistic representation of utterance A is constructed in the following stages. First, applicative expression of the predicative relation A is traverse to his route, the postman. Second, aspectualization of this predicative relation in the form of an aspectual operator of process A1, which is one of the values of the abstract operator ASPI, with the realization during the interval A1 and the unaccomplishment at the right boundary line J1 of this interval. This aspectual operator constructs an unaccomplished process from a predicative relation that is not aspectualized. Third, interlocking of the unaccomplished process relating to the predicative relation in the enunciative process is preceded by process J0 is carried out the interval J1. And finally, establishment of a temporal concomitance between the enunciative process and the predicative process by identification of the right boundary line delta J1 with the right boundary delta Z0. The following applicative expression expresses the result of the enunciative and aspecto-temporal analysis of A. To simplify the writings, we introduce the symbol P2 for the binary predicate associated with the verb traverse to, and the two nominal actant, or the two terms A1 and A2, associated with two respective nominal phrases, the postman and his route. This expression indicated that the enunciative process A0, I say, is carried out on the interval A0, including two metalinguistic clauses. We present the integrative process in the form of a natural deduction in the Genshin style, using combinators, leading to a definition expressed by an equivalence between operators, that is, by a compositional reunification, which defines a unique operator as the result of a functional composition of elementary operators. In the step 1, the expression of the conjunction between the predicative process and the relative temporal condition is included in the enunciative process. The expressions in step 1 and 7 are aspectually equivalent, that is, as abstract metalinguistic paraphrases in the metalanguage of logical grammatical representations. From this deduction, which is taken as starting point, we introduce some more integrated aspectual operators. We develop grammaticalized aspectual operators more complex than the aspectual operators, process A0, process A1, etc., which we denote by unaccomplished present, and an aspectual pre-morphological pressed process operator, to which we can directly associate a morphological trace at the level of the morpho-syntactic configurations of the Grace model. This will reveal the differences between the grammaticalized aspectual operator and the morphologized operator with the deduction calculation. In our analysis, the aspect unaccomplished present is not associated with the lexical predicate, as this operator unacpressed relates to the entire predicative relation instead. The grammaticalized aspectual operator unpressed, which integrates the temporal conditions, is in fact an aspectual temporal operator, with certain temporal constraint being closely linked to the choice of the more elementary aspectual operator plus J1. Meanwhile, the second operator, pressed process, which has the only lexical predicate as its operand, remains more specific to languages that express the verbal aspect attached to the verb. Building on the previous deduction, we start with the number 7 in succession. See the following table. We take up the previous deduction result in step 7, and we introduce several combinators in each step to get a normal form at the final step in 22. The definitive expression of the grammaticalized aspectual operator, unpressed, introduces a reunitarization in the form of a new unit, expressed using a complex grammatical operator that constructs the enunciative operator, elementary aspectual operator, and the temporal conditions on the boundaries associated with these two operators in the steps 13 of the preceding deduction. This operator aims to aspectualize the entire predicative relation. As for the definitional expression of the morphologized operator press process in the step 16, it has the lexical predicate P2 as operand. This operator is closer to the morphological content of a language, such as French or English, where the aspect and the tense are manifested mainly by the morphological markers of a grammatical tense of the verb, even if other linguistic processes can't complete the aspectual and the temporal information. Meanwhile, unpressed is an operator of the logical grammatical representational level in the theoretical framework of grace. Therefore, it is more abstract than pressed process. These representations are more general because they release grammatical rules that are more easily generalized to a typological group of languages than morphologized operators specific to the morphosyntactic content of its languages. We consider example A once again. The postman traverses his route. This utterance refers to a predicative analysis expressed by the applicative expression A prime traverse to his route, the postman. The conjugated verb traverses can be analyzed as the result of the application of morphological operator present on the binary lexical predicate traverse to. Thus, constructing a conjugated verb in the present tense, we set the definition of traverses. By the beta reduction relation between the applicative expressions, we obtain the following schema. Initiating the terms of the predicative relation by the respective lexemes, P2 equals traverse to, A2 equal his route, A1 equal the postman, we obtain the instantiated beta reduction schema. To the right of flash, we have the normal form of the expression that is located at its left, the latter having a structure closer to the morphosyntactic organizations of English. This normal form gives the interpretation of the morphologized operator pressed process, which concerns the binary lexical predicate traverse to. With an analysis analogous to the previous one, we can analyze other types of utterances in the form of the applicative representation. The lake is artificial. The main operators of this example can be analyzed as follows. In these definitions of operators, the predicative relation is represented by the aspectual operator state, and O1 represents the static interval of aspectual value. Thus, we have the following beta reduction. Ultimately, we have the four abstract aspectual operators that are grammaticalized in some languages and four respective morphologized operators, which are the respective linguistic traces of the preceding operators. We illustrate the aspecto-temporal formalization of an utterance in this presentation. In particular, we have looked at how certain aspecto-temporal analyses are treated in the same framework by means of formal calculations. These calculations are expressed in an applicative language accompanied by composition operator, the combinatory logic combinators. These combinators allow the construction of elementary aspectual operators and temporal relations. Topological and enunciative conceptualization resulting from theorization are formulated by sets of operators that relate to specifically predicative relations. We gradually move from an intuitive representation of the organization of aspecto-temporal values to a theorization based on the formalization of this aspecto-temporal concept. Computers have a binary system of 0 and 1, and always have a system in which one operator is applied to an operand. This work of converting natural language into a combination of operators and operands is applicable to any language, and inevitably produces a machine understandable representation. In conclusion, this presentation and this study shows a theoretical and logical first step in converting natural language into formal expressions that can be understood by machines. Thank you for your attention.